This is a quick demo of breaking Microsoft SQL Server TDE. The first step is to extract the database and other system data from the attack target server. This is a slightly unrealistic attack scenario in this case because the attacker probably wouldn't have a nice interface like this, but it serves the purpose. We're just demonstrating some method of extracting files. A straightforward copy of files from a live system obviously isn't going to work because the files will be busy. So instead we use a tool called Ninja Copy. And the way we run that is from a PowerShell with commands like this. The S1518 folder contains the DPAPI master keys. It may look empty, but in fact they're system files, so we just need to unhide them to be able to see them. So that's all of the files we need for data and key recovery. Just to also demonstrate, if we look at the extracted file, you can see that apart from a decrypted header, everything else is encrypted. It looks quite different to a normal database file where you can see a lot of text. Another likely source of database information is from database backup files. So they probably wouldn't be retrieved from the system like this. They might be from backup tapes or some other source. But here we're just copying the backup files so we can demonstrate recovery from those as well. And you would need the other registry Hive files and DPAPI files from the backups as well. But we already recovered those earlier, so we won't copy them again. That's everything we need to demonstrate both types of recovery, and at this point we will not need access to the target server at all anymore. Next step is to extract the keys from the data, the service master key in particular. And in this case I'm running that on Linux, but it can be run on any system. It's just a Python script. You can see here the highlighted key, that is the decrypted service master key. And we can also run the same command from the backup file, which will produce the same key. And we'll use this key in a later step to restore the encrypted databases. Okay, we're going to package up the recovered key into a restorable key backup file, and we're going to do that now on our own SQL server. So all the steps from here happen on our own temporary restoration SQL server. As you can see, this one has no tables, it's just a fresh install of SQL Server. We're going to use this tool called Win API Override, and what that lets us do is intercept system calls from applications. In this case, we're going to intercept the crypt unprotect system call. We add a special flag break after call so that after the crypt unprotect system call is finished, we can intercept the data. And we pop back to SQL query. And what we do is we back up our own service master key to a file, but we're not actually interested in our own service master key. So what we will do is intercept the call when it happens and substitute the original target key information instead, and then that will be written to the backup file. So if we take a quick look at that address, we can see a structure that contains another address, which is where the real key data is stored. So we then instead go there. That's in reversed byte order, of course. Now this is the real key. This is our local key at the moment, so we're going to replace that with the captured key from the target server and overwrite that. Here we can see it's successfully written. So now we can let SQL Server continue on, and it will finish writing the key backup file with our injected, our cuckoo's egg key information. Command's completed successfully, and there we have our backup file. So now we can restore the databases with the key. And the first step is to stop SQL Server. So we can now copy the files from the target server onto our own SQL Server, replacing the master database and also the database we're interested in. Now we restart SQL Server in single user mode with the -m flag, and what that does is tells it to ignore any authentication. So we can connect to it anyway, even though we no longer know what the login is on the original system. And we add a new user for ourselves so that we can log in normally. And we have to give it sysadmin access, of course. We can also reset the SA password to a password we know, but we don't need to do that here. So now we restart SQL Server without the -m, so it's just starting normally. And you can see now there is a secrets DB database there showing recovery pending, which is because we can't access it. It's encrypted. So we restore the service master key from our backup file, which contains the key of the original target server now. And now if we take the database offline and online again, or if we restart SQL Server, we will now have full access to that decrypted data. Simple as that. We can also do a recovery from .back files, database backup files, which is a slightly different process. It involves stopping SQL Server again, and restarting it in single user mode. Then from a command prompt we can run a SQL command. In this case we just restore the master database. That will stop the SQL Server, so we need to restart it again, and we want to do that in single user mode again so that we can add our own users back in. So once again we add our administrator user with sysadmin access. Then we can restart SQL normally and log in. Then we restore the service master key, same way as before, and restore our database of interest, and then we will be able to decrypt it. And that's it. That's all we have to do here.